This is the 13th video of the series Business Forecasting, and we were discussing time series decomposition. This is the part 2 of the video. In the last video, that is video number 12, I have discussed the part 1. So if you have not watched that video, please go to that video. I will provide the I button here in the top right corner. Okay, so in that video, we mentioned that there are two methods of implementing time series decomposition. Out of that, one method we already discussed in that video, that was the seasonal average method. In today's video, we are going to discuss the second method, which is the classical decomposition. I want to repeat this here also again that in case of seasonal average method, we are trying to separate out the seasonal index first and then the trend. So first we will separate out seasonal index and then the trend. In case of classical decomposition, the situation is exactly opposite. That means firstly we will separate out the trend component and then the seasonal component. So this should be the order. So before going to the actual spreadsheet, let me give a brief introduction of central moving average. So suppose you have a data like this. This is your seasonal data. Also it has some kind of trend. So suppose this is your data. Now how will you identify the trend? So one method is that you just pick the highs here and try to fit a trend line. That is one method. Another one is you take the low here, low points here, and try to fit a trend line. Then another point can be just to take the middle, that means the average of this particular observations, then the average of this particular observations, then the average of this and the average of this, and then try to fit a trend line. This is the method known as CMA. So in case of central moving average, you are trying to find one point that lies exactly at the center of this entire seasonal session. So for example, if you have an odd number of seasons, for example, say you have 5 seasons. So you are trying to find the center. So how will you find? You will take the average, just the average of the first five and then the next five, and therefore your average will fall exactly at the center. Like in case of 1 2 3 4 5, it will fall exactly at 3, and from 6 to 8, 10 also it will fall exactly at 8. So there will be perfect center, and the moving average of n period will lie in that perfect center. So when you have odd number of seasons, it is very easy to find the central moving average because it is just the moving average placed at the center of the series. But what will happen if there are even number of sessions? For example, for quarters, you have 4 quarters. For month, you have 12 months. So let us consider the monthly season. So like in our example also, we had 12 months. If you take the average of 12 months, then your average will fall somewhere between 6 and 7. It will fall at a place exactly 6.5. That is not 6 or not 7. So then how will you identify the average? It cannot be 6.5. It should be either 6 or 7. But if you do the average, it will come to 6.5. So the method is, then you go for the next set of 12 numbers. That means 2 to 13. and then take the average. So then it will fall in between 7 and 8. So that will be 7.5. So after that you take the average of these two, means average of these two. So therefore then it will fall exactly at this center, and you can then write that number, that will be your central moving average at the 7th position. So therefore if you have even number of seasons, then you cannot simply use the moving average method to determine the central moving average. We need to perform the moving average twice, and then we have to take the average of these two numbers. That means these two moving average. The things will be more clear when we will do it in the worksheet. So now let us come to the worksheet and implement this central moving average method. So this is the same worksheet that we had already used. See here in the sheet 1 we have already implemented the seasonal average method in our video number 12, and now in sheet 2 we will implement the central moving average method. So before doing that I will copy again the flow chart from the slide so that we can proceed step by step here and you don't miss out anything. So this is the flow chart. So what is the first point? First point is again note the trend. We have already noted down this is the trend, uptrending data with multiplicative seasonal model. These things are already discussed in the last video. I am again telling you that you should watch the last video, that is video number 12. Okay, so the next step is you compute the CMA, central moving average. So how to compute that? I told you that first we have to perform the MA2, MA12, then again MA12, and then the average of these two. How to do that? So first of all MA12, I am just zooming in so that you can easily see that. So always remember, when we will do the moving average, we will write this in the 7th position. So average of the first 12 numbers. Normally when you perform the moving average, the first 12 numbers average is written in the position 13, but in this case you will write this in the 7th position. If you are confused, then just remember that you will have to leave the first 6 rows. Why first 6? Because the number of seasons here is 12. So number of seasons by 2, that many rows you have to leave and then calculate the average of first n seasons. So you did this. Now you just have to copy this down. So for example, this is your from 2 to 13, average of 2 to 13 written in the place of period 8 in this way. Okay, so now MA12 is done. Now you have to calculate the central moving average. How to do that? I told you that one MA12 and then the next MA12, the average of that will give you the central moving average. So the average of these two numbers will give you the central moving average. That should also be written in the location 7. I must tell you here that in some books and in some texts, they will just make blank rows inserted between two observations and like this also, and then they will try to write the central moving average in the center. So all those things you don't have to do. You just have to remember that I will write the central moving average in location 7. Why location 7? Because you have 12 seasons. 12 seasons, 12 divided by 2 is 6, and you will leave the first 6 rows blank. First 6 rows blank, and then start calculating. So therefore, if you had 4 period seasonality, then what we will do? 4 by 2 is 2, so we will leave the first 2 and start from period 3 onward. So always remember, when you have, so n is the number of seasons, number of seasons. So n by 2, these are the rows to be left blank. So if you have n number of seasons, then calculate n by 2 and keep these n by 2 rows blank and start calculating moving average after that. So that is the only thing that you need to remember if you want to calculate central moving average correctly. So if you have done this, then you can copy here. Now see, another important thing here is you just have to make sure that in the end things are okay. Okay means, see here it is calculated like this, average of D139 to D150, but here the cells are blank, so therefore you cannot calculate this. So you have to delete these calculations. Here also this is blank, so only up to this, you see, you can perfectly calculate the average. Beyond this, you should not calculate the average, moving average. And here also you see 476.167, that is available, but the next row is not available. So you cannot write this also. You have to delete this, and all those things are deleted. So things to remember is, when you are calculating the moving average 12 and the central moving average, the average should be done up to that point where the data exists. So you will not calculate the average beyond this point because there is no such data to calculate average. Here also, if you calculate the central moving average beyond this, then this average will go to a blank cell. So that is not acceptable. So keep your average up to that point where you have a data. So that is the only point I wanted to communicate. So I am deleting these things, clumsy things. Okay. Now you have a central moving average. Always remember, the central moving average itself is the measure of your trend cycle. So this gives you the measure of this trend cycle. So therefore, what is the seasonal index? Seasonal index is, if you divide your number of passengers by the trend cycle, that should give you the seasonal index. And yes, indeed, this will give you the seasonal index. So make sure that this is calculated perfectly, that is number of passengers divided by the CMA. Now copy this to the end and be very sure that these are deleted. Don't have any entries for here. So up to this you can calculate. So calculate. Now seasonal index. Now see, these seasonal indices are varying in every year. So therefore we need to have a average seasonal indices. So what does that mean? That means, for example, this is the season number 7. You see, this is 1.167. In the next season number 7, it is 1.206. So we will calculate all the average of season number 7, and that will be the average seasonal index of season number 7. So we'll start from season number 1 itself. So we will use the average if function. Average if, what is the range? Range is this one, from here to here. Why not here? Because actually we want to calculate the average of this column G. So we don't want to enter the column C elements beyond this point. So therefore up to this you will select, and you know what to do. If you select this, then make sure to press F4 so that C8 to C139 is fixed, so that we can copy it afterwards. So this is your first argument. Second argument is criteria. What is your criteria? Criteria is your season number, that is 1, and then the average range, from where the average will be calculated. Of course, from this seasonal index column. So select this also. So always remember these two, that means C8 C139 and G8 G139 should be always symmetrical. That means these two ranges, this blue and this whatever color, these two ranges should be symmetrical. This cannot be like this is up to 12 and this is up to 7. That is not allowed. Okay, once this is done, make sure that this is fixed by F4, pressing F4 and close the bracket. So this formula is complete. So now I will copy this for the 12 seasons. So now you see this is the average seasonal indices. Now there is another problem here. Unlike the seasonal average method, if you calculate the overall average, this is not exactly equal to 1. Although this is very close to 1, but not exactly equal to 1. So our idea is you need to make sure that the total should be equal to 1. So for that we have another step, that is the normalized seasonal index. So what is normalized seasonal index? Normalization means this divided by this. So the seasonal index divided by the overall average. Always make sure H16 is fixed by F4 because we need to copy this down. And we copy this and we check here. See, now this is equal to 1. So this is not perfect. So I will wrap this text so that you can see. So these are the seasonal indices that we will use now. Now this will be consistent throughout the series. So now this was for the first 12. For the next 12 also the same values will be used. So I am just copying this until the end. Now end means 1961 also. Now from here you see, now let us go to the steps once again, the flow chart. In the flow chart it was told that compute the central moving average, that we have already computed. Then detrained the actual data. What does this mean? Detrained means dividing the passengers by the CMA. That is basically the calculation of seasonal index. Find the seasonal indices from the detrended data. So by using the averaging method and by normalizing, we find the seasonal indices. Then the next step is, from the next step onwards, the method is exactly same as that in the seasonal average method. That means the method that we already mentioned in sheet 1. So this is seasonalize, deseasonalize, then find the trend and then reseasonalize. So first you deseasonalize. How to do that? You have already learned in the seasonal average method that divide the passenger by the normalized seasonal index. So this will give you the deseasonalized data. Now copy this until the end, and here end means up to this, because beyond this the passenger data is not available, so you cannot divide. So up to this the deseasonalized data is available. Now the trend line. How to calculate the trend line? Using the trend function that we have already learned. Trend known Ys. So what are the known Ys? Known Ys are our deseasonalized data. Select that. So this much. You have to make sure that this is fixed by pressing F4. Then the next argument is known X. What is the known X? Known X is the period number. You see, I am not explaining this in very detail because I assume that you have already seen the last video where I have given these explanations in detail. So I'm not explaining this right now because this is a repetition. So you will select this particular period as your next argument here. So this is your known X. So once this is done, so new X, what is new X? New X is a period number. So period number 1, B2 is the new X, and then you close the bracket. So this is your trend line. This is your trend line estimate. And then what is your final forecast? Final forecast is your trend line into seasonal index. So this gives you the final forecast. So this is complete now. Now we will complete the chart also. Now in this video I will tell you another simple method to amend your chart. For example, if you have a chart already, if you want to add another series, maybe more than one series, like in this case, then what will you do? One traditional method is you go to select data and then you add the new data set that is already known, that I have used in the last video. But another easy method is you just go to the series you want to amend here. For example, trend line, you select the entire series, Control C, that means copy, and then select the chart and then Control V. If you do that, the chart will be already updated here. See, the trend line is now updated. Similarly, for forecast, you select the forecast series here, then Control C means copy. Control C is copy. Then select the chart and then Control V. You see this forecast is now updated here. So I will again change the color, change the format from gray to red. So this red line is your forecast line, blue line is your actual, and the orange line in between is the trend line. So now you can compare this chart with the earlier chart of the seasonal average method. Nothing very interesting, really different, almost same. So both the methods, seasonal average method and the method of central moving average, are giving you almost the similar forecasting result here in this problem. So you see, by looking at this chart, you can comment that both the methods are equally accurate. Otherwise, if you just want to be too much precise, go for the forecasting error calculation. That means MAD, MSE, and so on. So anyway, that is the entire process of implementing the central moving average method that we have discussed here. Now let us go to the slide again, and I want to mention few more points before closing this video. Now you see that in the decomposition method, both the seasonal average method and central moving average method seem to be too much simple. So simple that you may be provoked to use this model again and again whenever opportunity strikes you. But let me tell you one thing, this kind of simplicity is coming at a particular cost. So note that for decomposition method, we are using the same seasonal index for each and every year. So for example, you had 12 months and we calculated the seasonal indices, and for example, suppose 0.86 is the seasonal index of January. So for all January, for 1949, 1950, 1951, 1951 up to 1961, For all the January, we are taking 0.86 as our seasonal index. So that means the method is kind of static. And for trend line also, you use the regression method. What is regression? Y is equal to a plus bx. So this a and b, that means intercept and slope, you are not going to change it in every year. You once you calculate it for the series, it is constant for the entire forecasting process for any time horizon. So therefore both your trend line and your seasonal index are static. So this is one of the major drawback of this decomposition model, and therefore this model is sometimes often called as the quick and dirty method. So when you have the time series plot like this is textbook kind of plot. In actual reality you may not find this type of graph in any case. In textbooks you will often find this type of graphs, this type of plots. So only in those cases you will find that your decomposition method, it is either seasonal average method or the central moving average method, is really very good fitting. But in actual reality you need to use, or maybe you have to use, the Winters method, which is much more robust. Why robust? Because here you are using the smoothing coefficients alpha, beta, gamma. For alpha is for the level, and for trend and seasonality you are using beta and gamma. Smoothing coefficients, you are basically taking the feedback of the last period also and all the previous periods in order to find the trend and seasonality of the present period. That means this process, this Winters method, is dynamic in nature, it is adaptive in nature, whereas this decomposition method is static in nature. So therefore if you are finding that decomposition is too much easy and too much time saving for you, then don't just jump onto it to use it. Just think about it whether you should use it, or just select a more advanced model like Winters method. So that's all about time series decomposition method, and I have mentioned two methods, seasonal average and central moving average. Hope you have understood the contents of these two videos. So please use the comment section to inform me if there is any doubt. Otherwise, goodbye and thanks for watching this video.